This video is to explore what goes on when you change the size of your circle, either make it a radius bigger than 1 or smaller than 1, but what happens to those ordered pairs and how can you still work on a circle with radius different from 1. So I'm going to start with thinking about this ordered pair, which is on a unit circle, and the angle that I've got here is pi thirds. So here's my ordered pair, and since it's pi thirds, the x-coordinate is going to be a half, the y-coordinate square root of 3 over 2, because we know that the cosine of pi thirds is 1/2, and the sine of pi thirds is square root of 3 over 2. So what I'm going to actually do is draw a circle of radius 2 instead of radius 1. And actually, let's go all the way to 3. So here's 1, 2, 3, 1, 2, 3. Come all the way out here to radius 3. So I'm going to now extend this up to this ordered pair, try to think about what its coordinates are, and this circle of radius 3 is 3 times as big as the one with radius 1. That makes sense. So this length is 3, this length is 3, and circumference is 3 times as big. Kind of everything is 3 times as big. All the lengths are 3 times as big. So for example, this is going to be 3 times as big, and this is going to be 3 times as big as this and this. So for example, this is going to be 3 times a half and 3 times square root of 3 over 2. This isn't just true for this particular case. Let's say we're on a circle of radius r, and I don't know if r is bigger than 1 or smaller than 1 or kind of what, but it's a circle of radius r. I go out to some angle, call it theta, and I'm just drawing theta as if it's between 0 and 2 pi, but I could align it there just any old way. And I look at the coordinates of that point. Those coordinates are going to be r times the coordinates that exist with that same angle theta, but on the unit circle. So instead of cosine theta comma sine theta, it's going to be r cosine theta for the x-coordinate and r sine theta for the y-coordinate. So how does this do anything for us? It's like, okay, whoop-de-doo. But, certainly if you have a radius given to you and you have an angle given to you, all of a sudden you can figure out what the coordinates are. But I think there are plenty of problems, potentially more interesting, I don't know, different anyway, where you don't know the radius, you don't know the angle. You start out, say, knowing that I'm on a circle, don't know the radius quite yet, but I'm on some circle and my ordered pair is I got that backwards, is 3, one more, 3 comma 4. So I'm on a circle, don't quite know what the radius is, not really that worried about it right yet, but coordinates of that point, 3 comma 4. I don't know what the theta is. I could guesstimate it given this crappy drawing if I wanted to. It looks a little bit bigger than pi fourths, smaller than pi thirds, but I'm not so concerned with what that angle is. But looking back at what I said back here, the x-coordinates are cosine theta, the y-coordinates are sine theta. So I go, oh, okay. So 3 is r cosine theta, and 4 is r sine theta. Solving those for cosine and sine, all of a sudden I've got an expression. Okay, I don't know r, still don't know r, but I've got an expression for the cosine theta. If I just divide by r, I've got the cosine theta is 3 over r, and sine theta is 4 over r. So let me take a moment to figure out what r is, and the way I'm going to do that is to drop this down and say, okay, so this side is 3, This side is 4, this side is unknown. Let me just focus just on that triangle. This side is 3, this side is 4, this side is the hypotenuse of a right triangle, and the sums of the squares of the legs of a right triangle are equal to the square of the hypotenuse. And of course I chose this conveniently so I didn't have to worry about crazy numbers. 16 plus 9 is 25. Square root of 25, because I'm only looking at a length, so the positive square root of 25, which is 5. Okay, now we're getting somewhere. This guy is 5. That's 5. That's 5. And now this cosine of this angle is 3/5. Sine of this angle is 4/5. And so in general, in closing for this video, in general, you can always figure out, given some coordinates, if this isn't on a unit circle, given any old coordinates called x, y, which of course are some distance that you can calculate using Pythagorean theorem, some distance from the origin, and you can always calculate it with x squared plus y squared equals r squared. So if you're solving for r is the positive square root of x squared plus y squared. But what you can say is always that the cosine of theta, whatever this theta is, cosine of theta is going to be x divided by r. That's what we did back here. We said, oh, okay, since x is r cosine theta, because the circle is r times bigger or r times smaller than the normal unit circle, dividing by r, cosine theta is x over r. Sine of theta is y over r. Cosine theta is x over r. Sine theta is y over r. It gives us a way to talk about these cosine and sine as ratios of the coordinate to the radius, instead of just saying it's the x and y coordinate. And that's great. If you're on a unit circle, it is just the x and y coordinate, because r is 1, and x over 1 is just plain old x. But this gives us an extension to do with that.